Hey guys, Mrs. Duncan here. Hope you guys got to go outside yesterday and enjoy the absolutely gorgeous weather. So hopefully you had a good weekend and got some relaxation in the sun in. This lesson is going to focus on the part of the chapter on acids and bases where you're calculating pH and hydronium and hydroxide and how all of those are connected. Okay, so let's jump right in. So water breaks apart to form a small amount of hydrogen ions and hydroxide ions. So you see here's my water molecule, and then it's going to break apart into that hydrogen and hydroxide. So when you have a glass of water, most of those water molecules stay together, but there are some that dissociate and break up. And again, just keep in mind, guys, that hydrogen and water are BFF. They can't stay separate, so they're going to jump together to form hydronium. So when you have hydrogen, it's hydronium. So just know that when you see those two things, they're interchangeable because they essentially mean the same thing. Hydrogen has to jump onto that H3O because it can't exist by itself. So those water will break up into H and OH ions, okay? And this is called the self-ionization of water. So that double arrow right there means that the reaction can move forward, but that the reaction can also go in the other direction. So I can have my molecules split up into my two different hydronium and hydroxide ions, or they can come back together to form water. So again, I've mentioned this before, and I'll mention it a couple times throughout this presentation, that H3O is the same thing as your hydrogen ion in water. Okay, and I already did mention that that double arrow means that the reaction can go in either direction. So once you have equilibrium, that means that the same rate, both forward and backwards, is the same, and that concentration of your hydrogen and your hydroxide are going to stay constant at that point. So at equilibrium, everything is moving forward and back at the same rate. Okay, so pure water has a hydronium content of 1 times 10 to the negative 7th, and it has a hydroxide content of 1 times 10 to the negative 7th. So pure water, we already mentioned water breaks up into H3O and OH. So this is their value in pure water, okay? So here's my reaction here. I've got two waters, and I did two because some stay together, but some break apart here to show you where one of them have a hydrogen that jumps on to make H3O. So your H3O contents 1 times 10 to the negative 7th. Your hydroxide contents 1 times 10 to the negative 7th. Again, very small concentrations, but they are going to be equal concentrations. And so here's just a visual of that water with that hydrogen ion. Okay, this water being polar, this hydrogen is very attracted to it. So this is that hydronium ion that occurs once it's separated in water. So what does this mean? This means that you can actually create an equation that talks about the relationship between hydronium and hydroxide. So this Kw, this is the ion constant, and then the little w is water. So the ion constant in water equals your hydronium content times your hydroxide content, and that will always give you 1 times 10 to the negative 14th. So guys, this is your constant. This will never change. Okay, so you're going to use this equation to be able to solve. If I know what my hydronium content is, I can use this number and my hydronium to determine what my hydroxide content is. Or vice versa, if I know what my hydroxide content is, I can use this number and hydroxide to find hydronium. So these two numbers have a relationship, and they're creating this equilibrium expression right here. And this occurs at 25 degrees Celsius. So for all of our calculations, we're just going to assume that they occur at 25 degrees Celsius. Okay, so here is a picture of what that looks like. Again, you have your hydronium, your hydroxide equals 1 times 10 to the negative 14th. Okay, so again, because these are equal, and again, H3O, H, same thing, because they're equal to each other and they equal 1 times 10 to the negative 14th, I know that I can take this equation right here and I can rearrange it. I will always have 1 times 10 to the negative 14th. So if I know my H3O value and if I know my hydroxide value and I'm trying to find my H3O value, I would just take my hydroxide, bring it over, divide. That's going to give you your hydronium content. Or Vice versa, if I know my hydronium content, this right here, I'm going to solve for OH. Think of that as your X. Bring that over, divide. You can solve for OH. So if you know, you'll always know 1 times 10 to the negative 14th. But if you know your H3O, you can solve for OH. If you know OH, you can solve for H3O. Okay? So use that equation to help you go between OH and H3O. Okay, so pH. pH is a measure of how acidic a substance is. So again, potential hydrogen, how much hydrogen is in that solution. The more hydrogen there is, the more acidic your substance is. So pH, we already mentioned in my first video, is a logarithmic scale. So logarithmic scale is nice because it turns those super tiny numbers into nice whole numbers, because again, those concentrations are very, very small. 1 times 10 to the negative 7th is a pretty small number. So whoever invented the pH scale said, hey, let's do a log scale. It'll have nice whole numbers that we can talk about instead of trying to keep up with 1 times 10 to the negative 7th, just a very small number. Okay, so if I asked you to calculate pH, this is the equation that you would use. So the pH is the negative log of that H3O value. And again, I put H there just so that you know, but this is the same thing. So your H3O value. So if you know your H3O value, you'll plug that in and you'll do negative log on your calculator and then plug in whatever this value is. Whoever also invented the pH scale said that let's do positive numbers, which is why that negative log is there. So it's a positive 0 to 14 scale. So when you plug in negative log of your value, you're going to get a positive number. So for example, pure water, I know from that previous slide that my hydronium content in pure water is 1 times 10 to the negative 7th. So if I plug in negative log of 1 times 10 to the negative 7th, I get a pH of 7. So it's telling me that I have a neutral substance. Okay, anything below 7 would be acidic. Anything above 7 would be basic. Okay, so I'm using my hydronium content to give me a pH measurement. So those two are connected. pH and H3O are connected there. pH is just a measure of this content right here. Okay, so if we look here, if H3O is 1 times 10 to the negative 7th, then the pH is 7. Okay, actually, let's pull this up here a little bit. Okay, and if the H3O is 1 times 10 to the negative 6th, then the pH is 6. So notice that 1 times 10 to the negative 6th is actually 10 times bigger than 1 times 10 to the negative 7th. But I only see a difference of 1 in my pH scale. Okay, so it's going to drop from, even though this is 10 times bigger than this one, it's only going to drop me one number. However, because it's a log scale, that actually means that this 6 is 10 times stronger. It's 10 times more acidic than this number is. Okay, so what if I had a pH of 5? 5 would be 10 times more acidic than 6. It would be 100 times more acidic than 7. So it is a log scale. So even though this number is 10 times different, your log scale, they're going to drop by 1, but it's 10 times stronger every time you move down. So the lower your number, the stronger your acid. Okay, same thing when you're going up for the bases. The higher your number, the farther away you are from 7, the stronger your base. Okay, what's kind of nice about when you have 1 times 10 to the negative something, when you plug that into your calculator, it's just a pH of the positive value of this. So 1 times 10 to the negative 7th, the pH is 7. 1 times 10 to the negative 6th, the pH is 6. 1 times 10 to the negative 4 would be a pH of 4. Okay, so that's nice when you have 1 times 10. That's not always going to happen. If you do have 1 times 10, just your pH is just the positive value of your exponent. But not everything is going to be 1 times, and then you would just have to plug that into your calculator, and I will show you what that looks like here. Okay, I already mentioned this, that the more hydronium there is, the lower the pH. The lower the pH, the more acidic your solution. Okay, so here's an example. What is the pH if the hydronium content is 3.8 times 10 to the negative 5th? Okay, well, I can't just say, well, my pH is 5, because that's what my exponent is. That only works if this were 1 times 10 to the negative 5th, and this is 3.8. So you need to get out your calculator and you would type in negative log 3.8 times 10 to the negative 5th. Okay, and when you type all that in, please, please, please be careful, guys. When you plug in your scientific notation, please do E. Do not do times 10, raise it to the negative 5. I get a lot of error on pH calculations when people start plugging in the hydronium or the scientific notation. So don't plug it into your calculator incorrectly. So don't do times 10 raised, do E. That's going to really help ensure that you're going to get the correct answer. Okay, so again, when I do that, I get a 4.4. That is an acidic number. It's less than 7. Okay, so that is an acidic solution. Okay, so again, just as a reminder, the more acidic something is, the lower the pH. So the pH range for acids is 0 to 6.99. Acids produce more of those hydronium or hydrogen ions in solution. You can actually see a pH of -1 if you have a really, really concentrated acid, so super, super strong. You can actually go below 0. That's rare, and we won't see that a whole lot, but technically it actually can happen. Okay, neutral pH is a pH of 7, and then anything above 7, so 7.01 up to 14, is a base. And again, those bases produce more hydroxide ions in solution. All right, so let's look at an example problem. So what is the H3O value when the OH is 2.1 times 10 to the negative 9th? Okay, so remember we have that ion constant in water, that Kw equals, okay, that equation. I am being told right here, here's your OH value. How do you solve for hydronium? So you're going to use that equation, okay? So look here is your H3O value. So remember that equation that I showed you earlier, okay? You have Kw is 1 times 10 to the negative 14th. That equals your H3O value times your hydroxide value. So what it just told us in this problem was that the OH value, it gave us this value, 2.1 times 10 to the negative 9th. So because I'm solving for my H3O value, I'm just taking this and I'm going to divide it over. So 1 times 10 to the negative 14 is on top. My hydroxide value, 2.1 times 10 to the negative 9th, is on bottom. When you solve for hydroxide and hydronium, your 1 times 10 to the negative 14th is always on top. Then you're going to divide by H3O to find your OH, or in this case, we're dividing by OH to find our H3O. So this is the equation you will use. If you are given one of these, you will use this number and divide by the one that you know to find the one that you don't know. And again, I kind of mentioned here too, when you put this into your calculator, don't do times 10. Please do that E value, because if you don't put this in parentheses and do that E value, your chances of being incorrect just because you plugged it in wrong are significantly higher. Okay, so I'm going to plug in this in my calculator, 1 times 10 to the negative 14th, there's my constant, divided by what it gave me, 2.1 times 10 to the negative 9th, and I get my hydronium content. So in this case, my hydronium content is 4.76 times 10 to the negative 6th. Okay, so based on my hydronium content, now I can find my pH. So we know that pH, right, is the negative log of my hydronium value. So now here's an example. I'm going to plug in, here's my hydronium value. So negative log of 4.76 times 10 to the negative 6th equals 5.32. Okay, so you're going to just plug that into your calculator here. 5.32 is an acid. Okay, so that's an acidic solution there. And keep in mind that when you're finding pH, this is your H3O value, not your OH. So I can't just plug in negative log of this value to get my pH, because pH is a measurement of my hydronium. So I had to solve for hydronium first, then I could plug in negative log of that value to get my pH. Okay, so again, there's a couple different ways. There's a lot of information that you can solve from these couple equations here. Okay, what if you're given a pH? Maybe you have to go backwards. So I just showed you how to calculate your H3O, but what if I said, hey, my pH is 4? What's the H3O value? You actually can go the other direction. So you're going to use the inverse log on your calculator. And if you look on your calculator right above the log button, you'll see, generally it's in a different color, 10 raised to the x. Okay, so this is, you'll use the second button on your calculator, second log, to give you the inverse log. Okay, and this is the big thing right here that a lot of people forget to do. You need to type in the negative pH. So you're going to do the inverse log of the negative pH, and that's going to give you your hydronium content. Okay, so here's an example. What is my hydronium when the pH is 4.2? Okay, so in your calculator, you're going to plug in second log. Okay, it'll give you 10 raised. You need to plug in negative 4.2. And then when you press enter, it's going to give you your hydronium content, 6.3 times 10 to the negative fifth. Okay, so again, when you do this in your calculator, this is the inverse log here. Okay. And then make sure you do that negative 4.2, because that's going to be key to getting the answer correct. If you don't do that negative, then that's going to give you a wrong answer. So make sure that you note that and you don't forget about that part. Okay. You can do second log for your inverse log, or I believe you can do just the 10 with that little caret and raise it to the negative 4.2. Both should work. Both should work for you, either way that you do it. Okay. So couple of things here. pOH. pOH is not something that we talk about a whole lot. Most of the time that we're dealing with acids and bases, you hear the term pH used. So pH is definitely something that you'll see even in commercials. For example, I know that you've probably seen commercials for deodorant that talk about pH balanced. Okay, versus, you're a man versus a woman and you need a specific pH. Shampoos are another one, depending on if you have colored hair or not colored hair, if you want, a certain pH in your shampoo. So those are definitely things that you'll see. Sometimes companies will use that as a selling point. But pOH is not something that we do a whole lot of, but it is worth mentioning. So just like the pH value is the negative log of your hydronium, this is the pOH, which is the negative log of your hydroxide. So what is the pOH if your hydroxide content's 2.5 times 10 to the negative sixth? So you're going to plug in what you did for your other one here, and you're going to just plug in negative log, 2.5 times 10 to the negative sixth. Here's my pOH, okay? pOH and pH are not the same thing, okay? So pH plus pOH give me 14. So if I know what my pOH is, I can subtract that from 14 to find my pH. So those are connected, but we don't, like I said, we don't see a ton of pOH, okay? So this P, again, just negative log. So whatever you're looking at, if it's pH, it's the negative log of H3O. If it's pOH, it's the negative log of OH. So again, those are the two that are connected there. pH and pOH give you 14. And just like 10 raised to the negative pH gives you your H3O value, 10 raised to the negative pOH gives you your OH value, okay? So that kind of gives you all those. There's a lot of relationship between all of those things. So there's a lot of connection between your hydronium content and your hydroxide content and your pH and your pOH. So what's going to happen? Your assignment is going to look like something like this. You're going to be given, there's a couple different things that you're going to do. You're going to do a hydronium content, hydroxide content, pH, pOH, and is it an acid or a base? So if you are given any one of these, you can kind of work yourself through. There's 6 total equations for this. So you can work yourself through and determine what you need to solve for. So for example, if I was given my H3O value, okay, I would plug in, remember my ion constant in water? So I would have to plug in 1 times 10 to the negative 14th. Oops. And then I'm going to divide that by my hydroxide value. And that's going to give, by my hydronium value. And that's going to give me my hydroxide. So if I do 1 times 10 to the negative 14 and divide it by H3O, I get my OH value. Okay. These two are connected. So H3O is connected to pH. So if I know my H3O value, I know my pH value. So again, if I know my H3O value, I do negative log of my H3O value. So 2.76 times 10 to the negative 1. That's a 1 there. That's an ugly 1, but that's a 1. Okay. So if I do that, I'm going to get my pH value. And my pH value was 0.56. That's a very low pH. It's a very, very strong acid there. Okay. And then my pOH, I can do 2 different things. I can do negative log of my OH value. That's going to give me my pOH because these two are connected, pOH and OH. So those are the 2 that are connected. So I can either do negative log of my OH value to find my pOH, or if you remember, pH plus pOH give me 14. So if I know that my pH is 0.56, I can just subtract that from 14 to find my pOH, which is 13.44. Okay, so that is 0.56. That's a very, very, very strong acid. So that is an acid. So remember that when you're trying to determine acid or base, you're looking at your pH value here. So all of these are connected. Okay, so if you're given any one of these, you can kind of work yourself through ones that you're missing. So say on the next one, you were given a pH. Okay, so let's just say maybe you were given a pH of 12. Okay, you would do your 10 raised. Okay, remember that inverse log, 10 raised to the negative 12. And when you do that, that's going to give you your H3O value. Okay, again, those are the 2 that are connected. So if you do the inverse log of, remember, negative 12, then that's going to give you your H3O value. Once you know your H3O value, you can divide it to find your OH. Okay, and you can obviously pH and pOH equal 14. So again, a couple different things, and then that one would be a base because it's a higher number. So it can give you any one of those, and then you need to use your equations to kind of work yourself through. So just keep in mind that H3O, your hydronium content, is connected to pH. So pH is a measurement of that hydronium, and then your hydroxide content's a measurement with pOH. So these are each are connected, and then with this equation, 1 times 10 to the negative 14, you get a connection between these 2. So they're all connected in one way or the other. So on your homework assignment, you'll be given one of those, and then you can kind of work yourself through to solve for the rest of them. Okay? All right, great job, guys.